Hello dear students, all of you welcome to Vidyan classes. Today we will discuss the 11th property of inverse trigonometric function and its application. Property number 11. Two sin inverse x is equal to sin inverse 2x into root of 1 minus s square. If x greater than equal to minus 1 by root 2 less than equal to 1 by root 2. Pi minus sin inverse 2x into root of 1 minus s square if x greater than equal to 1 by root 2 less than equal to 1. And minus pi minus sin inverse 2x into root of 1 minus s square if x greater than equal to minus 1 less than equal to minus 1 by root 2. Property number 11. 2 sin inverse x is equal to sin inverse 2x into root of 1 minus s square if x greater than equal to minus 1 by root 2 less than equal to 1 by root 2. Pi minus sin inverse 2x into root of 1 minus s square if x greater than equal to 1 by root 2 less than equal to 1. And minus pi minus sin inverse 2x into root of 1 minus s square if x greater than equal to minus 1 less than equal to minus 1 by root 2. Let us prove the first. Prove. Two sin inverse x. It is case 1, it is case 2, it is case 3. 2 sin inverse x is equal to sin inverse 2x into root of 1 minus s square if x greater than equal to minus 1 by root 2 less than equal to 1 by root 2. When x lies in this interval, 2 sin inverse x equal to this. In this interval, 2 sin inverse x equal to this. In this interval, 2 sin inverse x is equal to this. Let sin inverse x is equal to a, which implies and implies by x is equal to sin a. Since sine function is invertible when it is defined from close bracket minus pi by 2 to pi by 2 to close bracket minus 1 1. Since sine, so that close bracket minus pi by 2 close bracket to close bracket minus 1 1 close bracket is invertible, implies and implied by sine inverse, so that close bracket minus 1 1 to close bracket minus pi by 2 plus pi by 2 close bracket. Sin inverse x is equal to a, x is equal to sin a. When sin function is defined from this set to this set. Here a belongs to close bracket minus pi by 2 to plus pi by 2, and x greater than equal to minus 1 less than equal to plus 1. Sin inverse x is equal to a. A belongs to this. Every inverse trigonometric function represents an angle, and the sin function is invertible when it is defined from this set to this set. We have to prove 2 sin inverse x is equal to this result. When x greater than equal to this, less than equal to this. Sin 2a is equal to 2 sin a into cos a, which is same as 2 sin a into root of 1 minus sin square a, which is same as sin a is equal to x root of 1 minus sin square a is equal to 1 minus s square. Implies this sin 2a is equal to this. It is taken as equation 1. This function is invertible or not. If it is invertible, then it is true. Sin 2a is equal to 2x into root of 1 minus s square. 2a is equal to sin inverse 2x into root of 1 minus s square is true or false. It is true when 2a lies between minus pi by 2 plus pi by 2. Sin function is invertible when 2a belongs to this set. 2a belongs to this set or not. If it is in this set, then the function is invertible. Otherwise, false. Since x greater than equal to minus 1 by root 2 less than equal to 1 by root 2, we can write sin minus 1 by root 2 less than equal to sin x less than equal to sin pi by 4 x is equal to, what is the value of x? X is equal to sin a greater than equal to sin minus pi by 4. Sin minus theta is equal to minus sin theta. Sin pi by 4 is equal to 1 by root 2. It is minus 1 by root 2. X is equal to sin a less than equal to sin pi by 4. Sin a is equal to this. Implies this minus pi by 4 less than equal to a less than equal to pi by 4. Since sin is an increasing function. Since sin is an increasing function, sin pi by 4 greater than equal to pi by sin a pi by 4 greater than a. Increasing means f x2 x2 greater than x1, that implies f x2 greater than or equal to x2 greater than x1, that implies f x2 greater than equal to f x1, implies f is increasing. Since sine function is increasing, we can write a greater than equal to minus pi by 4, less than equal to plus pi by 4. Since sine function is increasing. Increasing function means x2 greater than x1, that implies fx2 greater than equal to fx1, which implies this 2a multiplying 2, it gives minus pi by 2. It is 2a less than equal to pi by 2. 2a belongs to close bracket minus pi by 2 plus pi by 2, which is equal to range of sine inverse. The range of sine function is this. 2a belongs to in this interval, implies this. When 2a belongs to this interval, sine function is invertible when the angle belongs to this set. Here 2a belongs to this set. Implies this sine 2a is equal to sine 2a is equal to 2x into root over of 1 minus s square is invertible. That means the inverse of the function is exist. Since 2a belongs to this set, when the angle belongs to this set, the trigonometric function, that is sine, is invertible. Its inverse is exist, which implies 2a is equal to sine inverse 2x into root over of 1 minus s square, which implies 2 into a means sine inverse x is equal to sine inverse 2x into root over of 1 minus s square. If x greater than equal to minus 1 by root 2, less than equal to 1 by root 2. Hence proved. Similarly, the other two cases can be proved. Other two cases means this and this. Proof is not necessary since the proof of the properties are not coming in the exam. You should memorize these properties with this condition. Otherwise, you cannot solve the problems. Clear? Clear? Okay, note down. Elements of Mathematics, page number 62, question number 3. Express the value of the following in the simplest form. In property number 11, we have discussed 2 sine inverse of x is equal to sine inverse 2x into root over of 1 minus s square. If x greater than equal to minus 1 by root 2, less than equal to 1 by root 2. Pi minus sine inverse 2x into root over of 1 minus s square. If x greater than equal to 1 by root 2, less than equal to 1. Minus pi minus sine inverse 2x into root over of 1 minus s square if x greater than equal to minus 1 less than equal to minus 1 by root. In property number 11. Property 11. 2 sin inverse x is equal to sin inverse 2x into root over of 1 minus s square if x belongs to this interval, and pi minus sin inverse 2x into root over of 1 minus s square if x greater than equal to 1 by root 2 less than equal to 1, minus pi minus sin inverse 2x into root over of 1 minus s square if x greater than equal to minus 1 less than equal to minus 1 by root 2. You should memorize all the properties. Here, point 6. Point 6. X is equal to 0.6. 0.6 greater than equal to minus 1 by root 2 less than equal to 1 by root 2. That is 3 by 5 less than equal to 1 by root 2. So the first formula will be used. 2 sin inverse x implies as 2 sin inverse x is equal to sin inverse 2x into root over of 1 minus s square. Since x is equal to 0.6 lies between in this interval. So this can be written as sin 2 sin inverse x is equal to sin inverse 2x. X means 0.6 into root over of 1 minus 0.36. 2 sin inverse x is equal to sin inverse 2x into root over of 1 minus s square, which is same as sin inverse 2 into 0.6 1 minus 0.36, that is equal to 0.64, which is the same as sin inverse 2 into 0.6 into 0.8, which is same as sin inverse 0.96. Clear? 2 into 0.6 into 0.8, which gives 0.96, which is same as 0.96. Since sin inverse x is equal to x if x greater than equal to minus 1 less than equal to plus 1. Here x is 0.96, lies between close bracket minus 1 and 1. Sin inverse x is equal to x. Clear? Okay, note down. Next, elements of mathematics, page number 62, question number 2x. Write whether the following is true or false. 2 sin inverse 4 by 5 is equal to sin inverse 24 divided by 25. 2 sin inverse 4 by 5 is equal to pi minus sin inverse 2 into 4 by 5 into square root of 1 minus 16 divided by 25. Since 2 sin inverse x is equal to pi minus sin inverse 2x into root of 1 minus s square. If x greater than equal to 1 by root 2 less than equal to 1. Here x is equal to 4 by 5. 4 by 5 greater than equal to 1 by root 2 less than equal to 1. Clear? Since x is 4 by 5 lies between close bracket 1 by root 2 1 close bracket. So we can apply this formula. 2 sin inverse 4 by 5 is equal to pi minus sin inverse 2 into x. X means 4 by 5. Root of 1 minus s square. S square means 16 divided by 25. Which implies as 2 sin inverse 4 by 5 is equal to pi minus sin inverse 2 into 4 by 5 into root of 3 by 5, which is same as pi minus sin inverse 24 divided by 25. It is given by 2 sin inverse 4 by 5 is equal to sin inverse 24 by 25. Therefore, 2 sin inverse 4 by 5 is equal to pi minus is equal to sin inverse 24 by 25 is false. 2 sin inverse 4 by 5 is equal to pi minus sin inverse 24 by 25. Here it is given by 2 sin inverse 4 by 5 is equal to sin inverse 24 by 25 is a false statement. Clear? Okay. Its application, question number 1. In question number 1, x 2 sin inverse plus sin inverse 24 by 25 is equal to dash. In question number 2, x implies as 2 sin inverse 4 by 5. 2 sin inverse 4 by 5 is equal to pi minus sin inverse 24 divided by 25, which implies as 2 sin inverse 4 by 5 plus sin inverse 24 by 25 is equal to pi. Clear? In question number 2, x we have proved 2 sin inverse 4 by 5 is equal to pi minus sin inverse 24 by 25. So 2 sin inverse 4 by 5 is equal plus sin inverse 24 by 25 is equal to pi. So the correct option is pi. Clear? So the correct option is pi. Clear? Okay, note down. Elements of mathematics, page number 62, question number 3. Express the following in simplest form. Second bit, tan pi by 4 plus 2 cot inverse 3. Let cot inverse 3 is equal to theta, which implies as tan inverse 1 by 3 is equal to theta. Since tan inverse 1 by x is equal to cot inverse x if x greater than 0. Here x equal to 3 greater than 0. Clear? Okay. Which implies as tan theta is equal to 1 by 3. Tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta, which is same as 2 into tan theta is equal to 1 by 3, 1 minus 1 by 9. Tan theta is equal to 1 by 3, 2 into 1 by 3, 1 minus 1 by 9, which is equal to 2 by 3 divided by 8 by 9, which is equal to 3 by 4. Tan pi by 4 plus 2 cot inverse 3, which is same as tan pi by 4 plus 2 theta, which is same as tan a plus b is equal to tan a plus tan b whole divided by 1 minus tan a into tan b. A means pi by 4, b means 2 theta, which is same as implies as tan pi by 4 plus 2 cot inverse 3 is equal to tan 45 is equal to 1 plus tan 2 theta divided by 1 minus tan 2 theta, which is same as 1 plus tan 2 theta is equal to 3 by 4. 1 plus 3 by 4 divided by 1 minus 3 by 4, which is equal to 7 by 4 divided by 1 by 4, which is equal to 7. Therefore, tan inverse tan pi by 4 plus 2 cot inverse 3 is equal to 7. Answer. It is the simplest form of tan pi by 4 plus 2 cot inverse 3. Clear? Clear? Okay. Fifth bit. Answer. tan inverse x by y minus tan inverse x minus y divided by x plus y. Tan inverse x by y minus tan inverse x minus y divided by x plus y, which is same as tan inverse x by y minus tan inverse x minus y divided by y whole divided by x plus y divided by y. Clear? Which is same as tan inverse x by y minus tan inverse x by y minus 1 whole divided by x by y plus 1, which is same as tan inverse x by y minus tan inverse x by y minus 1 divided by 1 plus 1 into x by y. X by y can be written as 1 into x by y, which is same as tan inverse x by y minus tan inverse x by y minus tan inverse 1. Since tan inverse x minus tan inverse y is equal to tan inverse x minus y divided by 1 plus xy. Clear? Which is same as tan inverse x by y minus tan inverse x by y plus tan inverse 1. Tan inverse x by y, tan inverse x by y cancel. It is a tan inverse 1. Tan inverse 1 is equal to pi by 4. Since every inverse trigonometric function represent a radian angle, therefore tan inverse x by y minus tan inverse x minus y divided by x plus y is equal to pi by 4. Most important question for the exam. It is also important. Are you clear? Okay. Note down. Question number 3, 90 bit sine 2 tan inverse square root of 1 minus x divided by 1 plus x. Or x is equal to cos theta. So sine 2 tan inverse square root of 1 minus x divided by 1 plus x is the same as sine 2 tan inverse square root of 1 minus cos theta divided by 1 plus cos theta. One plus cos theta, cos 2 theta is equal to 2 cos square theta. 1 plus cos theta is equal to 2 cos square theta by 2. 1 minus cos 2 theta is equal to 2 sin square theta. Implies this 1 minus cos theta is equal to 2 sin square theta by 2. So this can be written as 1 minus cos theta is equal to 2 sin square theta by 2, 1 plus cos theta is equal to cos square theta by 2, sin 2 tan inverse root of 1 minus cos theta is equal to sin square theta by 2, 1 plus cos theta is equal to 2 cos square theta by 2, which is same as sin 2 tan inverse 2 cancels, square root of this is equal to tan theta by 2, which is same as sin 2 tan inverse tan theta is equal to theta. That means theta by 2, which is equal to sin theta. Sin theta is the same as square root of 1 minus cos square theta. Cos theta is equal to x, which is same as square root of 1 minus s square. Is the answer. So the simplest form of this is the square root of 1 minus s square. Clear? It is the simplest form of sin 2 tan inverse root of 1 minus x divided by 1 plus x. Clear? Okay. Twelfth bit answer. Put x is equal to tan theta. X is equal to tan theta. Tan inverse x plus root of 1 plus s square, which is same as tan inverse x means tan theta square root of 1 plus tan square theta. Clear? Next, tan inverse tan theta is equal to tan theta plus 1 plus tan square is equal to sec square theta. Its square root is sec theta. Tan inverse tan theta is the same as sin theta divided by cos theta. Sec theta is equal to 1 by cos theta, which is same as tan inverse 1 plus sin theta divided by cos theta. Clear? 1 plus sin theta divided by cos theta, which is same as tan inverse cos theta by 2 plus sin theta by 2 whole square. Since cos square theta by 2 plus sin square theta by 2 is equal to 1 plus 2 sin theta by 2 into cos theta by 2 is equal to sin theta. whole divided by cos square theta by 2 minus sin square theta by 2. Since cos 2 theta is equal to cos square theta minus sin square theta. Here theta is equal to theta by 2. So cos theta is equal to cos square theta by 2 minus sin square theta by 2. Cos theta can be written as this. Which is same as tan inverse cos theta by 2 plus sin theta by 2 whole divided by a square minus b square, that is a plus b into a minus b. Cos theta by 2 plus sin theta by 2 is cancelled. It gives cos theta by 2 plus sin theta by 2 divided by cos theta by 2 minus sin theta by 2, which is same as tan inverse cos theta by 2 plus sin theta by 2 divided by cos theta by 2 whole divided by cos theta by 2 minus sin theta by 2 divided by cos theta by 2. Dividing cos theta by 2 in numerator and denominator. This by this is equal to 1. Tan inverse 1. This by this is equal to tan theta by 2 divided by this by this is equal to 1, and it is sin theta by 2. This by this is equal to 1 minus tan theta by 2, which is same as tan inverse 1 can be written as tan pi by 4 plus tan theta by 2 whole divided by 1 minus tan pi by 4 into tan theta by 2. Since tan pi by 4 is equal to 1. Which is same as tan inverse tan pi by 4 plus theta by 2. This can be written as tan pi by 4 plus theta by 2. Tan a plus b. Tan inverse tan theta is equal to theta, that means pi by 4 plus theta by 2. Pi by 4 half of what is theta? Tan theta is equal to x, theta is equal to tan inverse x plus which is same as pi by 4 plus half of tan inverse x plus cot inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. So tan inverse x is equal to pi by 2 minus cot inverse x, which is same as pi by 4 plus pi by 4 minus half of cot inverse x. It is pi by 2 minus half of cot inverse x. Pi by 2 minus pi by 4 plus pi by 4 is equal to pi by 2 minus half of cot inverse x is the simplest form of this. This is same as this. So the answer is this. It is the simplest form of pi by of tan inverse x plus root over of 1 plus s square is equal to pi by 2 minus half of cot inverse x. Clear? Okay. Note down. Next, xi sin cot inverse cos tan inverse x. Put tan inverse x is equal to theta, which implies x equal to tan theta, which implies 1 plus s square, which is same as 1 plus x equal to tan theta, tan square theta, which is same as sec square theta. Sec square theta is equal to 1 plus s square. Sec theta is equal to square root of 1 plus s square. Cos theta is equal to 1 divided by root of 1 plus s square. Tan inverse x is taken as theta, x equal to tan theta, 1 plus s square is 1 plus tan square theta, which is same as s square theta. Sec theta is equal to square root of 1 plus s square, cos theta is equal to 1 divided by this. So, sin cot inverse cos tan inverse x is equal to, it is taken as theta, sin cot inverse cos tan inverse x is taken as theta, cos theta value 1 divided by root of 1 plus s square. It is theta and this value is cos theta is equal to 1 divided by root of 1 plus s square. So the result is sin cot inverse 1 divided by 1 plus s square. Put cot inverse 1 divided by square root of 1 plus s square is equal to alpha, which implies cot alpha is equal to 1 divided by square root of 1 plus s square, which implies 1 plus cot square alpha 1 plus 1 divided by 1 plus s square. Since cot alpha is equal to this, 1 plus cot square is equal to this, which is same as s square plus 2 divided by 1 plus s square. 1 plus cot square alpha is equal to cos square alpha. Cos square alpha is equal to s square plus 2 divided by 1 plus s square, which implies sin square alpha is equal to 1 plus s square divided by s square plus 2. Cos square alpha is equal to this result. Sin square alpha is 1 plus s square divided by s square plus 2, which implies sin alpha is equal to square root of 1 plus s square divided by s square plus 2. What is alpha? Alpha is taken as this, which implies alpha means sin Alpha means it is taken as cot inverse 1 divided by root of 1 plus s square is equal to root of 1 plus s square divided by s square plus 2. But this result is the same as this result. Therefore, it is taken as, suppose 1. 1 implies that sine, cot inverse, cos, tan inverse x, which is same as, which is equal to sine, cot inverse 1 divided by square root of 1 plus s square, which is same as square root of 1 plus s square divided by s square plus 2. It is the simplest form of sine, cot inverse, cos, tan inverse x. Clear? Tan inverse x is taken as theta, x equal to tan theta, 1 plus s square is equal to sec square theta, sec theta is equal to square root of this. So cos theta is equal to, it is theta, cos theta is equal to 1 divided by root of 1 plus s square. So the given question can be written as sine, cot inverse, it is cos theta. Cos theta, it is theta, this result is theta, and the cos theta is equal to this. So this can be written as this. Again it is taken as alpha, cot inverse 1 divided by 1 plus s square is equal to alpha, cot alpha is equal to 1 divided by root of 1 plus s square, 1 plus cot square alpha is equal to this result, which is the same as s square plus 2 divided by 1 plus s square, 1 plus cot square alpha is equal to cos square alpha, is this result. Cos square alpha is equal to, implied cos square alpha is written as sin square alpha. It is the reciprocal of this, so the reciprocal of this is this. Sin alpha is equal to square root of 1 plus s square divided by s square plus 2. It is taken as alpha. So we will find out the value of sin alpha. Sin cot inverse cos tan inverse x is the same as sin cot inverse. This result is cos tan inverse x, cos tan inverse x, that is equal to cos theta. It is cos tan inverse x. Since theta is tan inverse x, the result cos tan inverse x is 1 divided root of 1 plus s square. Cot inverse sin cot inverse x, it is taken as alpha. The result is sin alpha. Sin alpha is equal to this result, it is taken as alpha. This value is alpha, sin alpha is equal to this. Cot inverse 1 divided root of 1 plus s square is taken as alpha, which is same as sin alpha. Sin alpha is equal to this. Clear? Are you clear? Okay. Note down.